triangle ratio of 0 degree and 90 degree. So we'll begin with a diagram. It's a bit weird. I mean, we'll understand in time, but the diagram goes like this. So we have a right angle triangle. Right angle at B. So we have C and A. So we're trying to look at C, 0 degree, So how does 0 degree look? And how will that triangle look? So to simulate 0 degree, what will I do is I'll start reducing angle C. So if I reduce the angle C, it will look something like this, right? So basically your diagram will change to this. If I further reduce it, what will happen? No, very small, something like this. It's very, very small. So we have B, C, and A, right? So as you can see, if I make angle C very small, AB reduces a lot. You can see a significant reduce in AB. While length AC and BC, the hypotenuse and the base, they look to be almost equal, right? So if you understand this, you are done with the derivation. So we're talking in terms of angle C. So we're looking at this is your opposite side and that's your adjacent side, right? Now, let's begin with defining the diagram. Consider triangle ABC with angle B being equal to 90 degree. So if angle C becomes very small, right, in terms of its value, almost close to 0. So mathematically, this is written as angle C tending towards 0 degree. Okay. So it's not at 0, it's tending towards become 0. If it becomes 0, then you won't have a triangle, right? So the idea of tending towards 0 makes it a lot easier to imagine. Then what happens? Then we have the opposite side, AB, also going towards 0 unit. Right? It becomes very, very small, is it not? It will be almost close to 0. We'll call this as equation 1. While your BC will be almost equal to the hypotenuse AC. Again, they won't be exact, but almost very, very close to, we can tell it's very negligible. Then we have sine of 0 is equal to sine of C. So we're looking at sine angle C becoming 0, right? So with respect to C, opposite is AB by hypotenuse is AC. Because AB is equal to 0, 0 by anything is 0. This is from equation 1. And next we have cos 0. Cos 0 is cos of C. Cos C is adjacent BC by hypotenuse AC. Since they are almost equal, it will be equal to 1. This is from equation 2. And next we have tan 0. Tan 0 is with respect to angle C, right? We have opposite by adjacent. The its opposite is almost equal to 0. So 0 by anything is 0. This is from equation 1. And so these are your set of values. Okay. It's kind of weird, but if you understand this diagram, this will make sense. Again, the value is so close that we can make it equal to 0, 1, and 0. It's because it is so close. You need to understand that it's so close that we can write this. Now, 90 degree, you have a similar approach. So we have a diagram which looks the same, and the concept is also same. So how do you link it? Let's see that. We have triangle ABC. So I'm going to make angle C very, very close to 0. So if I make it almost close to 0, what happens to angle A? Angle A with angle sum property, it has to become equal to 90 degrees, is it not? As C tends towards 0 degree, A will tend towards 90 degree. Make sense? Right? As angle C tends towards 0 degree, angle A will tend towards 90 degree. So basically, with respect to angle A, we have this to be our opposite side, that's our adjacent side, and that's our hypotenuse. So now again we can discuss. Consider triangle ABC with angle C, angle B being equal to 90 degree. Then we can tell as angle A tends towards 90 degree, right? Then AB will tend towards 0. BC will be approximately same as AC, hypotenuse. We'll call this as 1 and 2, same thing. Now we just have to write the ratios, that's it, nothing else. Then we have sine of 90, which is opposite by hypotenuse. So this is equal to 1. This is as per equation 2 from 2. Next we have cos of 90. Cos is adjacent AB by AC. Since this is 0, the whole ratio will be 0. And at last we have tan 90, which is BC by AB, right? Opposite by adjacent. But here AB is 0. Anything divided by 0 is undefined. So we'll write it as infinity. Okay. And this is your derivation for your 90 degree. So if you understand this diagram, it will make sense. If not, it will be difficult. Okay. So please try to understand the diagram. It's not that difficult. You have to imagine it to be very, very small. It's kind of just there in front of you. If you're not able to get it now, just take a day break. If you want to study something else or do something else, play or talk to a friend, just do that and come back to this topic again. You will understand the derivation better. Okay. Don't force it on yourself. It'll come to you. So now you can pause and have a look.